P of x here, we have Q of x, and then we have our R of x. And we want to show that P of x goes into all three. So it's a factor of. Any thoughts on how we could do that?
No.
Simplify all of them.
Simplify?
Yes.
Oh,
I don't think you want the word simplify then. Factor. Yep. So let's factor both Q of x and R of x. So Q of x factored, we want to multiply to get 12, but add to get 7.
X plus 3 and X plus 12.
Okay, that's the way.
I do not.
I forgot that it was x plus 3. I thought it was supposed to be x plus 2, so I was worried that we did something wrong. But no, you're right. So, and then R of x.
X plus 3 and X minus
So yeah, just factor in that one as well. Multiply to negative 24 at negative 5. So minus 8 plus 3. Now it does kind of help that they tell us P of x is x plus 3. So that's kind of what gives you like half the answer already. So it kind of gives you a little bit of a clue that that's going to be part of it. So this is enough to show that it goes into both. But then I want to show that that the Q of x plus R of x. So if I added those functions together, would P of x still be a factor based off of that rule we just learned today?
Yeah.
So I need to add these two together. So when I go to add them together, what do we get?
2x squared plus 2x minus 12.
Okay. So what we did here was we combined the Q of x and R of x, just combined our like terms. So x squared gives us 2x squared. 7x minus 5x is our 2x. And then 12 minus 24 is a negative 12. Now we're trying to check that P of x is a factor of that as well. So again, we will have to factor. What do you want to do first?
Take out a 2
Yeah.
X plus 3 and X minus
Yeah, so we're able to show that that also works. That should be a 3. So kind of interesting that it works for these, these polynomials, kind of bigger problems, that this is also, there's that x plus 3 that shows up in there. So we're showing that it's also a factor there. Okay? All right. So it's not always that a number is going to be a factor. So sometimes we have what we call a remainder. And you guys have used remainders ever since you were little when you did long division and you divided 4 into 25 and it didn't go in exactly and you had a remainder of 1. So remainders like came up, you remember writing like the little r, like R1, and that was your remainder. So if something's not a factor, we're able to break it down and make it so that we can still divide them, but then have a remainder. So let me try to write this in a better way than what they have here. So I'm dividing, so I'm going to do n divided by, let's see, what am I dividing by? D. So I'm dividing n by d. If it's not a factor, so d is not a factor of n, we will have a remainder. What we'd have then is that we can say that n would equal, d is going to get multiplied by some number, so q times d, and then plus r, which is going to be our remainder. I'll write this out another way. So let me show this to you guys kind of in the long old school way. 25 divided by, let's do 4. 4 is not a factor of 25. So what this is saying is that I can break this up still and talk about it with, so if you would have done this like when you guys did long division, remember dividing this way? 4 goes into 25 6 times, right? And then what's our remainder? 1. So used to write like that. Well, instead of writing it that way, the way we're going to write it in pre-calc is we're going to say that basically 25 equals that those two, 6 goes into, or 4 goes into 25 6 times, so it's going to be 4 times 6, and then we just add on that remainder. When I write it that way, I think it looks a lot more obvious. Yeah, 4 times 6 plus 1, that is 25. We knew that already, or we can be comfortable with that. That's all this is saying. It's just now we're going to use it with like kind of bigger values or maybe some algebra along with it as well. So that remainder theorem we're going to use here in a minute. I think we just had a break. Oh, I forgot to do announcements though.
Oh,
Yeah.
That's a good break.
Yep. That's good enough break first.
Alright. I don't even think there's that many new announcements. Read about the. Alright. Yes. So regionals against Brookfield Academy tonight at 7 for volleyball.
Yep, be there, be square.
Alright, well,
Theme is gender swap. Guys here.
I still can't read
let me
it.
square.
Okay.
That's no square.
Really?
It's not
Let
that.
me see. See.
That's assuming your 2 fingers are the same
No, you
length.
like this and then
And
you
be sure if they were.
Yeah, but you have to turn it. You should
You have to have 4 of these.
Yeah.
You have this?
You're literally just like this stuff.
Okay.
You know what? I'd make it really even. You can put this and then like that.
So, just a reminder that tomorrow night is the informational session for the travel abroad for
That's
next
a
summer.
rectangle.
So Italy, Costa Rica, Argentina, Ireland, Scotland next summer. Your family can register for the meeting. If you're curious about travel and those who are already signed up should be coming to the meeting, please see Ms. Rathke with questions. Our club will be meeting on lunch on Friday in the art room. If you'd like to hold an officer position, please plan on attending this meeting. Seniors, a representative from Jostens will be here on Monday, October 25th, to meet with seniors during AR in the high school commons. Information will be distributed regarding senior announcements, ordering, cap and gowns, etc. Please plan on attending this important meeting regarding your graduation. It's a big pain to have to do that after the fact, but we kind of figure out what you need, so make sure you guys go to that meeting. I mean, if you're here in AR, but if you can't be here for some reason, make sure you find a way to get here. Tuesday, representatives from VIP will be here on Tuesday for photo retakes. Remember that you can sign up to work out in the fitness center during AR every day but Wednesday, as long as you're in good academic standing. Sign up in the office for next week. And lunch, it's still nice outside, so you guys are all able to go. Thursday, there's a couple of different reps here. Inspire Sheboygan, 9 to noon, Concordia during AR. And then on Friday, again, if you're interested in jobs to the Department of State, diplomatic security, there's going to be a presentation about that.
No reason. I can't.
So, you guys will probably want to grab a calculator for this one because I'm assuming most of you don't want to do the long division for 6,784 divided by 93. Alright guys, let's finish up so you can have time for homework. We don't have normal AR tomorrow, it's Wednesday, so that's either ACT or ACP. So just so you can plan ahead for that.
Why is that a thing?
Yeah.
It's like a statewide thing that you have.
It's CCCR actually.
Yeah, right, I know, yeah. But no, like there's like state rules that we have to provide that college and career readiness stuff for you guys. Okay. So
Don't make fun of me.
they're asking us to do a quotient, which is division. So the real number just means the decimal. So we can actually just put this into our calculator the way it is. But this is going to help us to do that remainder theorem. I'll go like 3 decimal places here. So when I divided those two, I got 72.946. Now that does not really explain the remainder. So what we're going to do is rewrite this in a different way using that remainder idea. But I know already that 93 goes into this number at least 72 times. So that's the way we're going to write this. We're going to say 93 times 72 plus, and now this is where we're going to get the remainder from. So what we're going to do is basically figure out what 93 times 72 is. So grab your calculator for that. 6,696. And I basically want to find how close am I to that, so I'm just going to subtract those two. So I'm 88 away from that. So that's my remainder. So I'm 88 short of getting all the way to having it be exactly a factor. So we can express the number 6,784 this way as well. Now that's not going to seem super useful right now, but we're going to end up using that later in this chapter. So getting comfortable with writing that remainder. So that 88 would be considered the remainder if we were doing like long division, like the old school way of doing that. So where this kind of comes into play is something like this next problem. So if we're renting vans to take the whole school on a field trip to Madison.
Awesome. Let's do it. Pre-calc class and one field trip.
Yeah.
I don't know where we go.
Just go like a museum or somewhere.
Yeah.
Something.
Because I don't. The place Shorty took them was that like.
Yes.
Yeah, it was.
Yeah.
Take us-
It was team building.
Okay, team build for our pre-calc.
And you guys are all like skipping out of this class in like 2 weeks, or a few of you.
Yeah,
Just
you.
Yeah. So then
I'll drop us off.
when they
stay
leave the
there.
class, then take us.
No, when we're in the class, take it.
Some people won't be.
I don't know if I've ever, well, so I've done field trips for math, but not for a whole class. We've done like, we've gone to visit like actuarial science careers.
Can you do that?
We can't all go, they won't invite all of us. Alright,
Just have a sign up.
That
sheet
sounds
for
fun.
It's
us.
not like not like a science field trip, but like Discovery, like Discovery World or whatever in Milwaukee.
Let's go to Disneyland.
Disneyland. Perfect. We should be able to do Disneyland.
No.
Sign us up. Okay. So guys, let's finish up this last one. Remember, it's a little bit on the long side. It won't take you a long time, but there's more problems than we typically have. So it says school is renting 15 passenger vans to carry 250 students on a field trip to Madison. But there can only be 14 students in the van since one's a non-student driver, so we have to kind of account for that. How many vans does the school need? Write the solution out using the quotient remainder theorem. So again, this is kind of where that remainder is important. Thinking about what do we have left and how much, how many kids is that actually? Can we just leave those behind? Just kidding. Or can we take a smaller van at that point? So we're taking 250 and dividing it by what? 14. Because remember, kid can't drive a van. Okay, so we get 17.8586. Okay, so we definitely need how many vans? 17. Because 17 times 14 will get us a chunk of students there. So that's 238. But that means we left behind 12 kids. Not a big deal. Shouldn't be a problem. So there's still 12 left behind. So this is a case where now we have to talk about, does it make more sense to get a whole other van? Can we put them in a minivan? Probably not. 12 is still a pretty big chunk of kids. So we probably actually need 239 bands based off the fact that our remainder sold. 230. We all get our own band.
I mean,
So it should be 18 bands. Sorry.
I don't think just get balls. It seems more practical.
So many bands. Talking about like being deluxe, so when we were so again Cedarburg story, but like when we went to state for girls basketball, I think it was.
Oh.
Wow.
You went to state for esports.
Yeah.
So yeah. Now
But
you
they got us bands to go to watch them in Green Bay, and they gave us like the fancy bands. Like they took all the kids in the school. I mean, somebody paid for it, but like some rich parent, like the not the bands, the big coach buses. Yeah. So we like rolled up, and I
We
felt
went
ridiculous.
to, like, some of the fans to go to state wrestling, we all rolled up in coach buses.
Did you really?
Yeah, what, like,
Oh,
a couple years ago.
that's cool.
You weren't in high school yet?
Yeah, I know, that's why I was
We took a coach bus to state.
we don't even get to.
Did you?
And we went to